Hello everyone. Today the video I'll be making is for beginners, people who are starting to write strategies. What is a strategy? Is the program you are writing for any equipment or for the purpose of controlling the equipment. So before we have the AHU in front of us, and suppose you're starting to write the program by yourself for the first time. I'm going to show you how we'll consider the points, and it's a basic program. I know most of the time you have Visio strategies, Visio programs which are already there in the format, standard programs, and then you just make modifications. But the best way to learn is trying to create your own program. Make it a simple program and try to have the system operational. So that's what we will do today. So we will take a page from the Visio. I'll show you how to start from the scratch in Visio. So before us we have the Visio page open. Sorry. So what we'll do here, just focus a bit more here. Okay, so you see the Visio here, and then what we can do is go to Visual Logic, new drawing, then which controller you're programming. Is it a global controller like VCM, ACM, VLC? We'll just take a normal VLC, consider 853.1188 or 1600, whatever VLC. Select that, click OK, and then you have the page. So once you have the programming page, as you can see, the programming page is here, and then I'll show you. All right, so let's just go here, settings. Always make sure the end of normal. This is why I've didn't mention this in the last video. Always keep the sequence number highest, that is the end of normal. Without this you might have a problem compiling the program. So let this be the high number, end of normal. Then device settings, here you can actually adjust the inputs and also you have the input setup. Suppose you have input number 1 is a thermistor, temperature sensor, could be anything. Let's make it a 3K sensor. This is how you set up the analog inputs. And then you have the analog output setup. So whatever output you're controlling could be an actuator or command. So binary output. You can set up everything here in device settings. So once you're done there, you can enter your name, generic, whatever you want to. Let's make it test. Test. Okay, so you have to start creating your own programs, so that way you can learn better. And also when you're starting out fresh, you're just modifying the existing programs. It's important that you create your own programs also, makes it easier. So for our AHU, let's just basically create a program for turning on the fan. I'll show you what we need to do. So for a fan, we will need to give the command to the fan. So we have to consider the safety conditions. So let's take 6 OR gate. So here you have the OR gate. These are the safety conditions. We'll have a couple of safety conditions. You want to make sure before turning on the fan. And then let's try to have a structure. And then we want to make sure if everything is good. We'll turn on the fan, and so we have the command. Let's just create a very basic program for operating the fan. Okay, so let's make sure we have given the sequence numbers. So this is 100. Let's make this 110. the sequence number, you cannot have same sequences. Okay, so so the first thing we'll do, we want to make sure for the fan to operate we have the leak detector. Let's keep the fire and the leak alarms as the main criterion. Leak. Okay. Then you have fire. So let's make sure there is no water leak detection, there's no fire in the system, and then you can have, so this is what we use. Okay. Okay. Let's make sure this is the first one. So let's say we don't have any leak. Let's consider this is a binary input 1 leak, binary input 2 for the fire. The rest of them which you're not using, always remember to keep them as 0 or false. And output, let's keep branches. We have branches 0 to 7, so that's also the internal registry. So now you have the first module ready. You have the conditions where you have no leak. Always let's negate it, considering that these are all 0. So none of the conditions, if either of these conditions is true, this is what it means. If either of these conditions happen, if either of these conditions are true, then the system is not going to run. So now we'll place it here. So what this does, just take it here. All right, let's see. Okay. So if everything is false, then you can have the fan command here. So let's consider our fan command here. I'll just take another input, try to put here, output. Let's take it system enable. Take it system enable. So this is system enable. Here we can say control is right. So if the BR 0, that's our input. Okay, if it is 1, then you will have nothing. That means the system will not be enabled. If it's off, then the system is enabled. Okay, and then output, we can take a BR or a BD value. Just giving a basic program example. So based on this condition, you can have the BR1, you can have a delay. So what it does, so we'll have a delay and then we can start. So this is the delay on make. So remember I was telling you about the sequence. So we have 100, 110, let's make it 120. So you can write any number. So let's make a delay of 30 seconds when the system is enabled. Input is, we have the BO0. Sorry, let's make it as your 1. Okay, and the output, we want it to turn on the fan, or we want to enable the system, and then that is your let's just place it. Just giving you a very basic example of a program, so you can do it on your own. but you need to learn to create your own strategies. That's what we are doing today. It's a basic simple program to enable the system or the fan or whatever. So here, system enable, just write. It could be an AHU, AC unit, whatever system you're enabling. So you have a 30-second delay. So this is the simplest program you can write from scratch and can learn. So basically, if any system, AHU, AC, or any system you're working on, you want to make sure basic alarm conditions. It could be anything. So I've taken leak and fire. So there should be no, if there should be no leak or fire alarm. You can add a couple of more inputs. Yeah, 3. We can keep it. We can copy. See. So let's put one more. Let's input 3. You can have freeze stat. Should be no freezing on the system. Over here. Make sure. Okay. So you can add the safety conditions. So if none of these conditions are in alarm, like if you have a leak, it will be 0. So basically, let's say if it's a fire or a freeze stat alarm, you don't want the system to run. So I'll show you. So if any of these conditions occur during the time of the system operation, then you don't want the system to run. So you want the system to shut down or not turn on the system, and someone from the maintenance of the facilities will come and have a look at the system, make sure everything is good, and reset the alarms. So if there's a leak, then okay, so let's just remove the negate. Right now we are assuming the conditions are all 0, so it's not going to enable this. So everything is normal. I'll just remove them. So what we have here is a basic program logic. If any of these condition is 1, any of these inputs goes to 1, then that will energize this switch and you will have 0 output, and the fan or the system will not be enabled. If everything is normal, then you just have a system enable command. Suppose it's just the start of the day, early in the morning, time schedule. You want the system to check and make sure everything is good. So it will do that. And then you have the system enable command, and then that enables the system. And this is the command. Okay, this is the binary output. So you have 24 volt DC or 24 volt AC going to enable the command, whatever system it is energizing, with the fan or anything. This is the basic program you can write. And then you go to Visual Logic and you can check the file, and then you have send DDC to device. Okay, and then you can send this program, make sure everything is good. It compiles, make sure there's no issues in the program, you make sure your sequence numbers are all in order, there's no overlap. Then this is how you create your own program. Think of any simple strategy and start designing your own program. That makes it easier, so that eventually you will be able to write your own programs for the AHUs, AC units, chillers, cooling towers, pumps. So you start with a small strategy and then you grow. So this is for beginners basically. This is how you write strategies, and there your strategy is ready. So make sure all the alarm conditions are met. Then you have the intermediate logic and the end command. You want to turn on the system or enable the system. So all the safeties conditions are met. This is how you start designing your own system. So basically you have an option. You can go and look for the standard programs provided by the manufacturer or being used in a standard format in the company, but start designing your own program. So you learn, basically make 100 mistakes, but those mistakes means you're climbing the steps and learning more of what you want to do, how you have your own. See, there are a million ways to design strategy. Every single designer can have his own strategy. Strategy is nothing but the program and the logic you use. Some people might write 10 pages of code, you might write it in 4. So it's all dependent on how you want to design. So start with page number 1, learn a basic strategy, and then you can create your own logic. Hope this helps, and I'll continue making these videos so it can be a learning experience for everyone, and I also can grow with you. Thank you for watching.